Right. So since most robots are meant to be mobile or at least compact or portable, usually our control systems are in the form of embedded systems. Okay, so something that we embed on a certain body, right? So embedded systems normally have either the microcontroller or the microprocessor as the brain or the central computing device. Okay, so the brain of our robots can be either a microcontroller or a microprocessor. Okay, and in microcontrollers, we normally have that for simple embedded applications that require low power consumption and low cost. Typically use ARM CPU like what we have in our um no in our some of our um development boards. Okay, sorry. And it usually uses the von Neumann microarchitecture. But sometimes, especially in recent versions, we already have some modified Harvard architecture. When it comes to the instructor set architecture, microcontrollers usually use the RISC, the reduced instruction set computer. Um, On the other hand, we have the microprocessors, which are ideal for general purpose computing applications. So if microcontrollers are meant for simple but fast applications, microcontrollers are for more complex, although much slower, but at least more complex, and they can do multitasking. Okay? They are ideal for tasks that require more complex functionality and processing power. So they typically use the x86 processor and okay, regarding the microarchitecture, the von Neumann is also widely used. While the main difference is when it comes to the ISA or the instruction set architecture, the more commonly used is the CISC or the complex instruction set computer. Okay. In other words, when we are focused on the muscle stuff or the muscle, especially those requiring movement and immediate data acquisition, then we use a microcontroller. But for higher level of thinking, higher level of processing, especially for multitasking, we use microprocessors like what we have in our Raspberry Pi. Okay. Microcontrollers, usually we use an Arduino for beginners. Okay. We can start with Arduino or maybe an ESP board. All right. And speaking of which, Arduino is take note, it's a microcontroller board. So we have these parts that we can use for our robotic system. It has both analog and digital pins. Uh, Rather, it only has analog input pins and digital input-output pins. Okay, it normally doesn't have an analog output pin. All right, and but it depends on the version of your Arduino. You can have a higher version if you want, right? And of course, so those who are not new to this, um, Arduino, since it is a microcontroller, it doesn't have an OS on its own. Okay, so we need a computing device like our laptop um, for us to create our program or at least to modify our program and then upload it to our board. Okay, so the software that we have from our computer, once it is being uploaded to the board itself, for example, this one, this microcontroller chip. Okay, once we upload the software here, that software now becomes an embedded firmware. Again, that's an embedded firmware, right? And to do some programming more efficiently and more accurately, we normally use some libraries. Okay, Arduino has a lot of libraries that can help us make simple robotic systems. at ease. Okay? So on the okay, right before we talk about Raspberry Pi, I suggest you can explore this Tinkercad classroom. Just go to Tinkercad and then go to classrooms, attend this one, input this code. We have the instructions also, right? So Tinkercad is a popular 3D modeling, but more on our focus is more on the circuitry simulating and block coding software package that's accessible for free via a web browser. So you don't have to download this, you just need a Google account. And you can explore different projects like what we have in this class. Okay, so go through this link. You'll see we have the folder Introduction to Robotics, and we have, I think, at least six examples that you can explore. Those examples are closely related or involved in a robotic system. So I highly advise you should check these examples. Okay, so by the way, in Tinkercad, you can write codes, you can put your codes there, you can modify these codes, and then you can do the wirings. You can represent your circuit here, and then you can simulate if it works. Okay, you can see if your code works or not. Okay, so that's the good thing about Tinkercad. You can use this for Arduino simulation, right? On the other hand, we have the Raspberry Pi microprocessor board. So, unlike Arduino, which requires another computing machine where we write and upload our code or upload our code from, we Raspberry Pi can do those things on its own because it has its own OS or operating system. Okay, like this, in its own OS, it has a desktop where the users can directly interact with it. Okay, so one of the tools here is, of course, the IDE for programming our Raspberry Pi. Okay, so basically, just need to install the OS and then put that micro SD that consists your OS. And if you have installed correctly, then you can start with it. You can start doing your things in your Raspberry Pi board. Okay. And I cannot see easy ways or AC or free open source platforms for simulating Raspberry Pi. There are some, but they are not quite they are too limited. My personal advice is to explore Oracle VirtualBox. So this is a powerful virtualization tool that allows users to run multiple operating systems, including the one for Raspberry Pi. And you're going to run them as virtual machines on their computer. So it's like you're having a Raspberry Pi inside your computer. Okay? So I suggest you should explore this if you want to simulate your Raspberry Pi codes. Okay. And lastly, we should not forget our human machine interfaces or HMI. So this is what connects our robotic system and us human beings. Right? So there are many types of HMI. Maybe the robots can be interacted with using gesture-based features or using natural language like our speech. Okay, like what Alexa does, right? Or maybe wearables. For example, you wear something and then because you are the one who wears that controller, then you are the one that the robot must monitor and um maybe follow. Okay, like because you have that like what we have in Big Hero 6. Okay, the helmet thing to control the nanobots. All right. So that's a wearable also. Other things we have the virtual reality, for example, in advanced SCADA systems, yeah, big industries, big companies already use SCADA or supervisory control and data acquisition system, especially if you have a lot of robots and other machines already, and you want to control them and monitor them more efficiently. So we have the SCADA system. And virtual reality is a common interface already in such systems. Okay. Augmented reality as well. It's the same thing. So virtual reality, we get to um, put ourselves into the digital world. Okay, we can see the digital world. While augmented reality, we put the digital object in the real world. Okay, so mix them together, we have mixed reality. All right. So mixed reality is the one actually more applicable in SCADA and other advanced systems, including our robotic systems. Okay. Other things that worth noting for regarding HMI are smart sensors and RFID biometrics sensors. So they make our robots more interactive. Okay. So I think this would be the last. Okay, that would be all. Thank you very much for listening, and I hope you've learned something. See you in our next module.